Day 448 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3487, maximum unique subarray sum after deletion. The difficulty level is easy, but so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums. You are allowed to delete any number of elements from nums without making it empty. After performing the deletion, select a subarray of nums such that all elements in the subarray are unique. The sum of the elements in the subarray is maximized. Return the maximum sum of such a subarray. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. And before we get into an example one, let's go over the definition of a subarray. It says, a subarray is a contiguous, non-empty sequence of elements within an array. So a subarray has to be contiguous, meaning it has to go in order of elements, or not in order or of indexes, sorry. So we have to, like, this would be a subarray, this would be a subarray. It's not a non-contiguous subsequence. A non-contiguous subsequence would mean we were able to delete some elements and still just keep the same order. But in a subarray, we have to keep all of the elements that are next to each other, right? So we can't just take an element here and then add this element and then add this element like we could in a non-contiguous subsequence. In a subarray, all of the elements have to be contiguous, meaning they have to be next to each other already or in order of the indexes, right? So it has to go from index 0 to index 1 to index 2, or from index 2 to index 3 to index 4, or from index 1 to index 2 to index 3 to index 4. You know what I'm saying? Something like this. Or like this would be a subarray. You know what I'm saying? This would be a subarray. This would be a subarray because they're all in order. It's not, and it's contiguous. That's what contiguous means. So now that we understand what a subarray is, let's get into example one. So in example one, we have the input nums equals an array of integers 1, 2, 3, 4, and 5. The output is 15. Explanation says select the entire array without deleting any elements to obtain its maximum sum. So in this example, as you can see, the elements are already unique, and there's no need to delete any elements, because if we delete any elements, that's just going to make the maximum sum smaller than it already is, right? So 15 is the maximum sum that we could generate by adding all of these elements together. If we take any one of these elements or we delete any one of these elements, the the maximum sum will be less than 15. But we want the maximum sum, or the maximum unique subarray sum. And so for this, we could just use the whole array and we'll get 15. Now, if we had negative numbers, that might be an example where we would delete some numbers. Now, let's take a look at example 2 where we can delete some numbers as well, because once again, we want a maximum unique subarray. So in example 2, as you can see, the input does not contain all unique elements, i.e. the multiple ones. So let's go through it. In example 2, we have the input nums equals an array of integers 1, 1, 0, 1, 1. Output is 1. Explanation says delete the elements from num 0, which is 1, so we delete this one. Delete nums 1, which equals 1, we delete this one. Delete nums 2, which equals 0, which is this right here, delete that 0. And delete nums 3, which equals 1. Select the subarray 1, so now all we're left with is this 1, and the maximum sum of 1 by itself will be 1. So as you can see, we need a subarray of unique elements. So we could delete 3 of these ones just to make the 0 and 1 unique. Now, once we have the 0 and 1, it doesn't really make a difference if we delete the 0 or not, because the sum or the output will still be 1. But in this example, we delete the 0 as well, and we're just left with this final 1, and thus our output is 1. So let's take a look at example 3 where we do have some negative numbers. So in example 3, we have the input nums equals an array of integers 1, 2, -1, -2, 1, 0, and 1. This time the output is 3. Explanation says delete elements nums 2, which is -1. So we'll delete this -1, and then we'll delete and deleted nums 3, which is -2. So this -2 right here. So we're going to delete these two elements right here, and then we're going to select the subarray 2 and 1, because after we deleted these two elements, now we need to create a subarray from what's left over, which would be this right here. So out of this array that's left over out after deleting the -2 and -1, we're just going to pick these two elements right here, which will get us 3. We can't go 1, 2, 1, because once again the elements in the subarray have to be unique, right? So if we have 1, 2, 1, we would have 2 1s and it wouldn't be unique. If we did this if we did this subarray, answer would still be 3, so that could work. Or if we did this subarray, now we have a -1, and that would shrink the answer to 2, which is less than 3, because once again we want the maximum. We want to return the maximum sum of each subarray, so there's no need for this -1. All we need is this 2 and 1 to achieve our maximum sum of the subarray, and that's how we got it, and that's why our output is 3. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution is not that difficult at all, nor is it that much code. So let's get into it. Now, the first thing we're going to do is we're going to convert the input array to a set, which will remove the duplicate values for us. So for that, we're just going to say let s equal set, open up the parentheses, and pass in nums. So remember, a set just removes all duplicates, and it's going to make the this nums array with all the unique characters, with only unique characters. Now we're going to calculate the sum of all positive numbers in the set. So we're going to say let pos sum equal s.filter, open up the brackets, say $0 is greater than 0. Then we're going to come outside of the bracket, say dot reduce, open up the parentheses, 0, comma, plus. So let's go through this line right here. What this is going to do, through this line right here, what this is going to do is it's going to take this S and it's going to filter out. So this $0 is going to represent each element in S. So it's going to filter out each element in S that is greater than 0. So it's going to get us all of our positive integers that are in S. Then once we have all of our positive integers that are in S, then this reduce right here is going to start to count from 0, and it's going to add all of those elements together from 0. So we're going to start from 0, then it might add the 1, then it'll add the 1, so we'll be at 1. Then we'll add the 2, we'll be at 3. We'll add the 3, we'll be at 6. We'll add the 4, we'll be at 10, and so on and so on. That's what this dot reduce does. So that's going to get us, once again, that's going to get us the sum of all of the positive integers in S. Boom. Now, if the sum of positive integers is 0 or less, i.e. all of the values are in S are less than 0, then we're just going to return the maximum value in the set, or 0 if the set is empty. So for that, we can use a guard statement, say guard possum is greater than 0. That's going to make sure that possum is greater than 0. Then we can say else. We can open up the brackets and we can return s dot max, open up the parentheses, question mark, because it's optional, and put a 0. Otherwise, we could just return the sum of all the unique positive numbers by coming underneath this, or we could just say return pos sum, because remember this right here already adds all of the elements and gets the maximum sum for us. So we could just return the pos sum right here. And that's all she wrote, y'all. So let's go ahead and give it a run before we submit it. Told y'all solution wasn't that bad. It's accepted. Let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.